Question 17 asks you to expand these binomials using the binomial theorem. And if you remember, the binomial theorem uses either combinations or Pascal's triangle to help you multiply out things that normally would take FOIL. That would be the quantity x plus 4 times the quantity x plus 4 times the quantity x plus 4. And you certainly could do it with FOIL, but it would take a while, especially a fourth power here. That would be very tough. So pattern, if you remember, Pascal's triangle, you've got a 1, and then a 1, and a 1, and a 1, and a 2, and a 1, and a 1, and a 3, and a 3, and a 1, and a 1, 4, 6, 4, 1, and so on. And of course, you can always just add any two numbers together to get the number that comes beneath it. So 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, and so on. You get 1, 5, 10, 10, 5, 1 on the next line, and so on. So anyway, what the binomial theorem says is that basically for your 0 power, first power, second power, third power, fourth power, fifth power, and so on, these will be the coefficients of your expansion, or at least your basic coefficients. So for example, if I want x plus 4 to the third, that's a third power, which is going to be this 1, 3, 3, 1 line. So I can write down a 1 and a 3 and a 3 and a 1. And if you remember, your highest power of x is going to end up being x cubed, and your powers of x will drop by 1 for each additional term, and then your last term will just be a constant with no variable. Now, the other value, you're going to start out with a 4 cubed in this last position here, and then you're going to have a 4, basically it'll decrease by powers. It'll be 4 squared, 4 to the first, and so on, and then this is all being added up. So this one here would be x cubed plus 12x squared plus 4 squared is 16, 16 times 3 is 48, 48x plus 4 cubed is 64, and that would be my final result. So you can crank these out relatively quickly. For part 2, it's x minus 3 raised to the fourth power. So I'm using this fourth power line, the 1, 4, 6, 4, 1. And again, you're going to have decreasing powers of x. So you're going to have x to the fourth, and you're going to have x cubed, and you're going to have x squared, and you're going to have x. And you're going to have increasing powers of the last term. But be careful, really read that as a negative 3. So you're going to have a negative 3 to the fourth, and you're going to have a negative 3 cubed, and you're going to have a negative 3 squared, and you're going to have a negative 3 to the first. And the negative 3 to the 0 power would just be 1. All right, so you can get something that looks kind of like that. And then you can just work everything out. So you're going to get an x to the fourth. Negative 3 times 4 is negative 12, x cubed. Next one, you're going to get 9. Negative 3 times negative 3 is positive 9. 9 times 6 is 54, x squared. And then negative 3 cubed, that's negative 27. Then you're multiplying out in front by 4. That's going to be 108, technically negative 108, x. And then 3 to the fourth power is 81. It'll be positive. And you get something that looks like that. And also something, notice, because you have a negative here in front of the 3, every time you take it to an odd power, you get a negative. Every time you take it to an even power, you get a positive. So you're going to get alternating positive and negative signs in your final answer. Okay. The last one here was 2x plus 5 raised to the fourth power. It's still going to be the 1, 4, 6, 4, 1 pattern. Now, instead of decreasing powers of x, it's going to be decreasing powers of 2x. It's whatever's in this position. So it'll be 2x to the fourth, and 2x cubed, and 2x squared, and 2x to the first. And 2x to the 0, of course, is just 1. And then you're going to have decreasing powers of 5. You'll have a 5 to the fourth, you'll have a 5 cubed, you'll have a 5 squared, you'll have a 5 to the first. And you can just work all this out. 2 to the fourth is 16, so you've got 16x to the fourth. 2 cubed is 8. 8 times 4 is 32. 32 times 5 is 160, x cubed. 2 squared is 4, 5 squared is 25, 25 times 4 is 100, times 6 is 600, x squared. 5 cubed is 125. 125 times 2 is 250. 250 times 4 is 1,000. X. And then 5 to the 4th power is 625. And so that's going to be your final answer there. So that's how the binomial theorem works to expand binomials. Okay. We also talked about a twist on the binomial theorem, which works for the same reasons, but it actually uses a little different setup with combinations usually instead of Pascal's triangle. I think we've discussed this before. So Pascal's triangle, you can generate, you can take the combination of 0 taken 0 at a time, and that's going to give you the 1. And then you can take the combination of 1 taken 0 at a time and the combination of 1 taken 1 at a time, and that's going to give you 1 and 1. And then you can take the combination of 2 taken 0 at a time and the combination of 2 taken 1 at a time and the combination of 2 taken 2 at a time, and that's going to give you the 1 and the 2 and the 1. And then you can do the combination of 3 taken 0 at a time and 3 taken 1 at a time and 3 taken 2 at a time and then 3 taken 3 at a time. Running out of space there. And it would generate the 1, 3, 3, 1 line, and so on and so forth. So what I'm going to show you is going to be the equivalent of this, but I'm going to use the combinations to do it, and I'm going to do it with probability instead. So 18 says, in a particular week in December, it's 30% likely to snow on any given day. Find the probability that it snows exactly the given number of days. And again, this is based off the binomial theorem. The process is usually referred to as Bernoulli trials. So, so the idea here would be that technically, technically, you're taking your 100% of things that can happen and you're breaking it up. 30% of the time it snows. It either snows or it doesn't. So technically you're saying snowing is 30%, not snowing is 70%. And we're doing this for a week, so you'd be taking it to the 7th power and then basically using what we talked about in the earlier steps to try to figure this out. It sets up a pretty nice pattern though. So for example, if we wanted 3 days out of 7, that would really be 3 days of snow and 3 days of no snow. But anyway, instead of trying to list all the different orderings and the ways that you could possibly do that, you can really just say, I want to pick, out of those 7 days, I want to pick 3 of those days for it to snow, okay? And you can use a combination to do that. And then you can say, all right, those 3 days that it snows, they have a 0.3 chance of happening, and we want it to happen 3 days. The other 4 days, I want it to not snow, and each of those has a 0.7 chance of happening, and I want it to happen for 4 days. And you can basically just multiply that out. So the combination of 7 choose 3, for example, is 35. So you're taking 35 times 0.3 cubed times 0.7 to the 4th. And if you work that out, you're going to end up getting 0.227. I'm rounding here, but approximately 0.227, which is about 22.7%. Okay. Now this one asks you to do a whole bunch of different ones. So 0 days. Now really that could just be, you know, it doesn't snow the first day, and it doesn't snow the second day, and it doesn't snow the next day, and so on. I mean, you could really do that without using Bernoulli trials. But anyway, just to follow the pattern, that would be the combination of 7 choose 0, and you want it to snow 0 days, so 0.30 to the 0 power, and you want it to not snow, so there's a 70% chance of not snowing, and you want that to happen 7 days. And so if you work that out, you're going to end up getting 0.0823. I'm going to write that as about 8.2% chance of that happening. Didn't actually say what to round to, but I think that's appropriate in this problem. If it snows exactly 7 days, that would be the first and the second and the third and the fourth and the fifth and so on. You really don't need Bernoulli trials, but you could do 7 choose 7. You want it to snow 7 of the days, and you want it to not snow 0 of the days. And if you work all that out, it ends up being the same thing as 0.3 to the 7th. My calculator is going to give me scientific notation. It's 2.187 times 10 to the negative fourth. Remember, when you're working with scientific notation, you're really dividing by 10 4 times there. So that's going to move the decimal 4 places back, which is 0.000287, which is a very small percentage. I'm not even going to round that. It's going to round to 0% actually if you rounded it. Okay, so very unlikely if there's a 30% chance it's going to snow 7 days in a row. Okay, 2 days. So that means it snows 2 and it doesn't snow 5. So we're going to do a combination of 7, choose 2. We want it to snow 2. Whoops, sorry, that should be an exponent of 2 there. And we want it to not snow 5 days. Okay? And so the combination of 7, choose 2, we can go ahead and do that. That is 21. And then you're taking 21 times 0.3 squared times 0.7 to the 5th. And that's going to be about 0.318. So about a 31.8% chance that it snows exactly 2 out of 7 days, which is a pretty decent chance of that specific event happening, okay? So anyway, we've got our A, and our B, and our C options here. Okay, D is 4 or 5 days. Okay, so that's an or, so we need to add our probabilities. So we want the probability of 4, and we want the probability of 5. So 4, that would be, we're doing 7 days, choose 4. You want it to snow 4 days, so that's a 0.3 chance happening 4 times. You want it to not snow 3 days, that's a 0.7 chance happening 3 times, okay? Combination of 7, choose 4, that is going to be equal to about 35, and then we'll multiply this out. Okay, so this probability is about 0.09724, and it actually goes farther than that, but we're just going to use that. Okay, that's snowing 4 days. Snowing 5 days, so we want 7 days. We're choosing 5 of them to snow. How many different ways we could do that? So 0.3 taken to the 5th power. We want to not snow, which is 70% chance, 2 of those days. Okay, so 7 choose 5. That's going to be 21. It's going to be 21 times 0.3 to the 5th times 0.7 to the 2nd. And that's going to be about 0.0250047. Okay, and if we add those 2 probabilities up, because we want this, and or means that we're going to add, we add both of those up, we're going to get about 0.1222, which is about 12.2% chance of happening.